I'm Thomas Schmid, Regional Product Line Manager for Laser Tracker and Absolute Arms in Asia. And here I have Nick. Nick, maybe you introduce yourself.
Yeah, my name is Nick Strucker, responsible for sales for Laser Tracker worldwide, supporting Thomas also for his task in his region. Yeah. Hello, everybody.
Thanks for your support today. Today we are talking about roller alignment. So we have, but first, before we start, I would like to give a small introduction into Hexagon. So we have a very strong base and foundation in metrology, first stationary, and then we move to a little bit more portable. What you see today is our laser tracker. This is an acquisition from Hexagon in 2006, and then you see also Absolute Arms and so on. And further on, we have, for example, Vero as production software today, and CAD/CAM solution, MSC acquisition. So we are moving now to a complete manufacturing solution. So that's it from the company side. I would like to start with the agenda. So why we do a roller alignment and when. So when it has to be done, and the location means in which industry and which application is it used. And then we will also show you how to do it with some video examples with Nick as the application engineer. And then we have a quick summary, and then feel free also to ask questions on the right hand side. You have a tool and all your questions will be answered during the session or afterwards. So why we do a roller alignment? So to reduce wrinkles in paper or foils. So when they are not parallel, one side is more loose, one is more tightened. So, or if you have a coating machine, so we have a consistent coating over the whole process, or also to have higher safety, higher production speed. We can decrease the wear when there's less tension on the roll, decrease vibration. Vibration also generates noise, so when you can decrease the vibration, you have also less noise, and then you can also decrease the maintenance interval when there's less tension on the motors, for example. This will also reduce energy, and then you have also reduced risk of downtime because there's less pressure on the motors, for example, or the roll itself. And then, of course, you have also a higher and consistent product quality. Now we are talking about when we do the alignment. So that could be right in the beginning on the setup of the machine, during maintenance or regular maintenance intervals, when you repair a part or replace a part, when you do a machine general modification, or when you kind of realize there's a quality drop, a delamination of your product, so you have a increased level of waste, when you detect some corrosion, or when you see there's a wear out of machine. So that kind of plays together with maintenance or part replacement. So for the tracker portfolio, I would like to hand over to Nick to give you a small introduction into the laser tracker world.
Yes, so this is our portfolio of laser trackers, 3 different models, all of them with nice capabilities. Let's start from the left to the right, AT403. This is our most portable system, our entry-level laser tracker, and very, very well suited for instance, the application of roller alignment. The system is capable to measure on a reflector up to 10 measurements per second on a reflector, up to 10 measurements per second, but also capable to measure with a so-called B-probe into areas which are not so easy accessible. Then we have the ATS 600, can measure up to 1000 Hertz, can do measuring on a reflector as the AT403, but also measure direct scanning to the surface reflectorless. This was introduced into the market in 2019. And then we have the 8930, 8960. In a way, our flagship model. It's the system can measure up to 1000 Hertz, can measure also so-called 6 degrees of freedom. So what you see next in the accessories, it can measure on our T probe and scanners to be able to, let's say, in much more resolution, scan surfaces of objects in a large volume. So these are the 3 different models of the laser trackers. Trackers can also be used for automation, what you see in the right side, to calibrate robot, but that's not the target of today's presentation here. What you see on the left side, further down on the left, it's the roller alignment kit. We renewed it, and today we want to present it to you and how it's used, the roller alignment kit. Details of it will be explained. Then reflectors is the base of every laser tracker measurements, different reflectors available. We have red ring reflectors, corner cube reflectors, where basically the corner cube is in the center of a mechanical sphere, 1.5 inch, 7/8 inch, or half an inch diameter, depending on the application. The customer chooses the best one of them, or the break resistant reflector, what you see there on the left side. Opening angle, so relative angle, how the beam can enter into the reflector is plus minus 25 degrees. What you see on the lower side, we have there the super cat eye reflector, which has an opening angle of 75 degrees. It's mainly for station movement, for specific application, the ideal reflector. Now, these are reflectors where you need direct line of sight from the laser tracker to it. Our trackers are capable to measure up to 80 meters, the 600 and the 960, and 160 meter radial distance with the 8403. So probes, the so-called T probe, what you see there on the upper side, this is this kind of device with exchangeable tips. So a T probe is very, very useful. What you will see later on also when you have really a jungle of rollers which you need to check, which you need to measure there, a T probe can be very useful. And then the B probe further down, this is the probe which can be connected to 8403. And then we have all the scanners, the LAS and LAS XL and the T-Scan 5, which can measure up to 200,000 points per second to scan surfaces, typically to compare against the CAD model. So this is the overview about all the accessories which can be used together with our laser trackers. Some other characteristics of laser trackers as such. So systems are very mobile. 8403, 7.5 kilogram, can measure the volume up to 160 meters. All trackers can be used based on battery power. And especially for roller alignment, think about a large machine where you want to put the tracker with the tripod on the tripod. It's very, very useful if the system is used battery power. Also smart connectivity, so Wi-Fi connection to your application computer, maybe to a tablet PC, which you have then close to your, let's say, area where you want to adjust your roller. So Wi-Fi is really very useful. Cables are not really liked for this type of application. Orient to gravity, very useful functionality. So the system itself can have an internal leveling sensor. And so all the measurements you do in X, Y, Z coordinates. Typically, the XY is then the horizontal plane in the orient to gravity system, and the Z is the axis going up, so the height information. This can be done very, very precisely, and orient to gravity functionalities in all of our trackers embedded. Power lock is the functionality that when you interrupt the laser beam, so the laser beam going to the reflector being returned, somebody walks through the beam. This happens all the way. Then the system automatically jump back on the reflector. That's a functionality we introduced in our trackers in 2009, so 11 years back. Highly useful functionality. Today we cannot think how useful this is because it's a natural, let's say, functionality of every laser tracker we are providing to the market. So all-in-one system, so very compact system, 1 kilohertz data output is possible. Overview camera, so when you want to use the system remotely, there is an overview camera built in that you can, on your screen in your application software, drive the system remotely through the camera. IP54, extremely relevant. Typically, this industry is very, very harsh environment. A lot of dust can be there. Outdoor measurements also, some rain could be there. So IP54 certification of all our 3 different laser tracker models. Every laser tracker has a built-in meteo station. A meteo station measuring basically the temperature of the air, the pressure of the air, and the humidity of the air, and does automatically, in a way, in real time, correct for the changes on the temperature or the pressure to give you always the right distance back. So in this way, we can guarantee with the 8403 and with the 8960 an absolute distance accuracy over the full range of 10 microns. So 10 microns, highest accurate absolute distance meter we have built in our 2 laser trackers. So the meteo station allows us to have this really very precise distance measurement, and it corrects automatically. You don't need to care about it. And every tracker we provide to the market comes out with a 24-month warranty. Good. This was introduction to laser tracker, and just some pictures about the ATS. The functionality which we added to basic laser tracker 1 year ago is the capability that we can, through the Oreo camera, select the perimeter or through the CAD file. And then we basically define the scanning, let's say, characteristics, or the point-to-point distance. And then we do automatic scanning from distance, as you have already seen shortly in the introduction video, which you see here in the animation. So without the reflector, we can scan directly onto the surface in a distance up to 60 meters with quite a high accuracy. So this nice functionality comes on the top of the basic laser tracker functionality, which is basically measuring on a reflector in the large volume. Every laser tracker has a horizontal range of 360 degrees, so all around, endless, and vertically from 35 degrees to the gravity down, more or less up to the zenith. All that is possible in regards of the volume, measuring range, measuring area with every of our laser tracker. Good. This was my introduction. I now hand over to Thomas and showing the video ATS 600 in let's say in quite a tough industry. All the systems are made really for harsh environment.
Good, that was a video with a very big roll. And now we are start talking about many different applications. So a quick overview about the application we selected for you. You have here a very big bending machine with a lot of rollers need to be aligned that the tube is also bending in the right way. We have also a lot of application with rollers in printed, flexible packaging, coating, laminator, bending machine, and also very big grinder machines or kiln application. And then we see, when we go to the next slide, we see Yes, an example from tire production. Tire production comes with a lot of different layers, also to make the tire very robust. And then in the middle, it will be blown some air out and then kind of baked that the rubber has also this shape. A lot of rollers are there which need to be aligned as well. Oh, that was too quick. Then corrugating, a case study was here from US, an example. Corrugating client wanted to increase the operation speed. So as I mentioned before, but he also saw some twist delamination. So one side was maybe a little bit too tight, the other had some baggy edge, so the quality was not quite right. And with this roller alignment, all these problems could be solved, and also 10% increase of operation speed. And then, of course, the quality, the end quality was much better with reduction of waste as well. So a lot of cost saving as well. Other example here I found on LinkedIn, a conveyor belt alignment, all these small rollers, and then other example are battery. So we see Tesla is on a run right now. They need a lot of battery production. A lot of layers need to be combined and produced. So battery production has a lot of potential for roller alignment, and this kit we will show you afterwards. Aluminium industry, all kind of metal industry, plastics, plastic foils and films, also this a lot of application. And then we see beside with those applications, we some example of steel production. So we have here also again an example from UK, I think one from Russia, and the other left also from UK with the ATS 600 roller alignment, and in the middle the AT 403, and then you see with the Aero very small with a huge range of more than 300-meter volume. You can cover all these applications. And for a little bit more handy application or ergonomic application, we have also a solution in the cold rolling mill, or also kind of a steel in the steel industry with a T-probe. So really to have a little bit handier solution with programmable button, and then it's a one-man operation solution. When you explored a little bit the Hexagon webinar page, you might find already this example from OASIA alignment. We had a very nice application and case study from US, where they explained the paper industry. So what was the advantage and disadvantage, or mainly the advantage of using the tracker for this alignment? You see a lot of roles need to be adjusted in a short amount of time. You see also an example here on the left-hand side from South America, Technimex, and here on the right-hand side again from US. And I like this picture a lot because it shows also the drier section with a challenging environment. So it's usually very hot there and humid. So the IP54 protection of our tracker is very much value added, and not only from the sensor, also from the controller. In this webinar and also here, I would like to show you an additional solution. Beside the roller, they need also a very flat surface in the Forgineer to make the paper more constant as well. So starting, okay, so this case is in this case is everything inside. We had a roller alignment kit before, but now it's possible to use it also with the 1.5-inch reflector. So in this box we have the base plate with a circular spirit and 3 adjustable screws. So we mount actually this pin then to the mark on the floor. to set up the x-axis. And the x-axis is key. This could be 100 meter long, so along the whole machine, and it has to be long because this ensures also the accuracy of our axis. So you have actually two of them with a reflector, and one is gives us also the 0 position somehow, but the x direction will come from our laser tracker. So we have a nibble inside, and this is the x-axis. So you see also here the measurement points, which can be pointed with the base plate, and then we have the coordinate system in the very first axis. This is our origin then, and then we have very important the x and the z-axis, and the y is a little bit less important in this roller alignment application. So we will show you, or also Nick will show you then afterwards, the real example, and to have it a little bit with a better overview, we had a test set up to show it to you a little bit better. So on the bottom left, you see actually also a line on the screen. This is our baseline. So in our test center, we created a baseline. We had one tube, and then we measured on this tube and created videos for you. And the right picture shows actually the measurement with the overview camera. So we were able to see the base plate through the overview camera. And then we measure the tube. So on left side, base plate, you need two of them, and the right side, we have the roller adapter. The roller adapter comes with two spring spirits. So one for the horizontal mount to adjust the x-axis, and the other one spirit to adjust the z-axis of the tube. And a lot of things can be modified. We will see this a little bit later also in the videos. We have also for small magnets we can change, so it's holding himself. This is according to the size of your diameter. So adjustment, the adjustment is only done with the spirit. And we had a question this morning also from Germany. Why is the spirit accurate enough? It is, and we will show you why. And the same also for the x-axis for the positioning. So we have actually one position in front, and I think we'll let here our expert Nick again explain it to you. Thank you, Nick.
Okay, what you see here on the left side, let's say for the alignment in Z direction, so in the height. Typically, you can think a roller has a fixed end. That's where you maybe can not so easy move, and then you have the other end, which is maybe the mobile end, the end which you can adjust. So putting the roller alignment kit on the end, bringing it on the top position, why and how I explain later, and then set basically this height to 0. That's what you can do, and then basically doing the same thing with the kit when you go to the right side. To the right side, to adjust by the X direction. X direction, front side, fixed end, and then the flexible end, back side. So showing here again the concept, basically, you have position 1, fixed end of the roller, adjustable end of the roller. That's where you move later. So first on the fixed end, set the relevant coordinate. On the upper end now it would be the Z coordinate to 0, move it to the end behind, and then adjust to 0. Maybe going back to the fixed end again, because maybe this has also moved a little bit, because you have maybe not exactly put it on the turning point, but you're much closer, setting to 0 again. In the software, it's just one mouse button, and then going to the adjustable end again. Good. So doing this from the front side to the back side, magnetic prismatic adapter, adjustable to the diameter of the roller. very easy to use in that way. And what you see here also, front end, back end for X direction. So basically, typically you would adjust maybe first the height, front end, back end, and then X or inversa. But each axis for itself. That's a classical way how rollers are adjusted, because maybe the moving capability is also one axis after the other. Good. So having now set to 0 on the front, putting it to the back end, and then really adjusting the roller with wrenches, with the hammer, with whatever is available, what is possible. Then you see directly on the screen, on your mobile device, on your wrist, iPhone on your wrist, showing the result, just the X coordinate, the deviation, bringing that to an acceptable within tolerance value. Now here 29 microns, that was the adjustment done based on laser tracker measurements with a tracker position which allows you to have line of sight to the front end and to the adjustable end. Good. Having this adjusted, you could move back to the front end again, set to 0 again, and going back to check and verify if the adjustment was done in a very good way. So now please just look to the values on the screen. This illustration is there to understand what's going on and why we can really adjust the set direction quite in a very precise way, even when we position the kit, this let's say magnetic part, not so precisely on the top. So we put it on the top. Now you may just have a look at the values, 54, going up to the right side, going to 62. And now we may have looked what was the set value at the beginning, 0.1 millimeter, in the end 7 microns. So it moves around 100 microns while X is moving by 8 millimeter. The reason is in a way clear when you think you walk over this big, if this would be a big roller and you would walk over it. The height difference you need to go up is quite small when you need to walk quite long along the X-axis. That's the nature of any circle. So based on this, if you just want to adjust the set, the position left, right in X direction is not so relevant. It's a magnitude less important than the changes, the accuracy you see on the set direction. So you will adjust this with the spirit on the front side approximately, move it to the adjustable end, adjust the height, and then you go to the right side and do the same thing to adjust the X-axis, to set X-axis first to 0, and then go to the adjustable end to adjust the X. And if you have very much adjust the X, maybe you need to go back and adjust the set again a little bit. So this is adjusting a roller perpendicular in a way to the reference line, which was given by the 2 points on the floor, shown by Thomas before. So you have these reference marks on the floor, which stays with the machine for the life of the machine for 20, 30, 40 years. These are the reference marks on the floor, which you reference all your alignments onto it. So 2 points plus the orient to gravity capability. That means 1 point is really defining in a way X, Y, Z, 0. The other one is just defining where the X-axis goes through. The height is defined by the built-in, let's say, orient to gravity capability of the sensor. Good. So this was adjusting and why this roller alignment methodology works in a very, very nice way. So thinking about application like this, a roller jungle, so line of sight. If you stay in one corner of a big machine, 100 meter long, you cannot adjust all the rollers from this position. You typically always need to move your tracker more or less in front of a roller to be able to adjust that specific roller. Then to another roller 2 meters aside, typically you need to move the tracker again to another side. That's why battery power is so relevant, and a very portable light tracker is also very, very useful. And the quick process to align only 2 points, which you leave with the base plate in position for the whole alignment process, is very, very beneficial. Good. Now you are in front of the roller and you adjust, as explained before, with the roller alignment kit, or also with other let's say, methodologies as now shown here on this video sequence. So we can also use a T-probe. And we can also measure basically a circle on the fixed end. So we can measure a circle on the fixed end. That's the green circle you see there. Knowing the coordinate system, so the XZ plane is fixed with the 2 reference points. Now, basically, you can adjust the movable, the flexible end of the roller to this circle. Just the Y coordinate will change. So that's basically the idea now. So we measure now a reference circle on the fixed end, and now we adjust the other end to the same circular position. And thanks to T-probe, we can also do that when we really have very, very narrow rollers, where you need really to go down in between the rollers with the T-probe, even with longer extensions, so you can adjust 400, 600, 800 millimeter extensions on the T-probe. That's one of the key benefits of this technology with the AT960. Good. Other methodology, when you measure the front end, even the circle as a reference, and now you can put a reflector on the back end. I say just somewhere, because you now project basically the position of the reflector to this nominal circle. If you adjust this, let's say, close to 0, then you are in this position correct. You can now move the reflector to an upper position, adjust a little bit the height, moving to the right position, adjust in this direction. So you can really build now this flexible end with a reflector based on the 3D capability basically of the application software. Good. On the right side, you see the same type of measurement when maybe the roller would not be magnetic or the roller would not be easy accessible. You can do the same thing with the T-probe. With the same reference, as you see in the upper right corner, we have really the X-axis by the 2 points. Z-axis is upright by the oriented gravity capability. This is the reference plane. A front circle was measured, and now you project basically the second circle, the position there to this circle in a way to a virtual cylinder, which sits perpendicular on the XZ plane. Good. Then when you have done your adjustment, you could verify, you can report that. Now seeing here live XZ deviation. And if you are within tolerance, everything is green, you are happy, you can document that and move on to the next roller. And move on to the next roller means typically you change the position of a track to another position, measure again your 2 reference points, measure the fixed end, and adjust the flexible end. Good. That was the methodology. Any question you have maybe later on, feel free to come back to us at any time. I now hand over again back to Thomas.
Yes, thank you, Nick. So very key after the verification is, of course, then also the report. We have PCDMS and also specializer macros and templates. We are also willing to share with you. So you see my email address at the very end, thomasschmid@hexagon.com. Please feel free to send me. Very, very helpful also for our customers or service providers to do roller alignment, which also include a lot of roles, as you can see here. So we already coming to our end. So I would like to start with the end. So I show you the summary. So the advantage is really about reducing waste. Wrinkle parts, delamination is removed. So also money can be saved, environment can be saved. So the increase of production uptime because of less maintenance, or the maintenance interval is longer. The energy saving, because the motors are less challenged, I would say. Increase the maintenance interval, I just mentioned, increase the production speed. So when the rollers are smoother, I would say, this would also increase your throughput, and this also is then beneficial for the customer. So he earns more and he reduces cost. I mentioned already the macro or the measurement plans from Special Analyzer. Feel free to also send me or Nick an email. I don't see many questions during the session. I would like to thank you for your attention, and I hope you stay safe and healthy.